Okay, this is trial 1, explosion, verification of conservation of momentum. We got the blue car over here with a mass of 0.756 kilograms. We've got the green car over here with a mass of 1.22 kilograms. The blue car is set with a plunger that will spring out when the little button is pushed. So here on this red car, we can see that there's a little plunger right here, and when I push that button, that thing comes flying out. So that creates an internal force that's going to push the two cars apart. So again, we push that back in, sometimes push that button down so we can get it all the way in, and then when this gets tapped, comes flying out, we get a force. This value right here, this velocity, 0.358 meters per second. And for the blue car, we're going to use this value right here, 0.589 meters per second. These two velocities, they represent the edge of the screen. Sometimes these picket fences, the light beam that comes across catches the edge of that and interprets that as part of that 5 centimeter block. But we know that can't be velocities of 40 and 70 meters per second. That's flying across the room. This one makes sense. If we take the spacing that the photocell is reading, which is 5 centimeters, and we take 0.05 meters and divide that by the gate time, which is 0.085, that's how long the light was blocked, 0.085 seconds. We divide that, we get 0.589, and that's where that value comes from. So that's how we know that's the legitimate velocity right there. So in this case, we have an unknown mass. I'm going to put the unknown mass against this wall because we're expecting it to go in this direction. So we're going to put the mass right up against the edge here. Get these guys lined up. Alright, so the mass, this is the second trial here on our sheet. The mass of the blue car is still 0.756. The mass of the green car is now an unknown mass. So that's unidentified. And your objective is to solve for the mass of the unknown. Our velocity after the collision for the green car is 0.634, and our velocity after the collision, again these two don't make any sense, is 0.494 meters per second. So you'll need to record those. This is the third part down here, the elastic collision. In an elastic collision, the blue car is going to come in, it's going to push into this, like this, it's going to push in and bounce off. So that's what's going to happen here with the elastic collision. They bounce off of each other. I've changed the window here so that the velocity of the green car is not seen, because that's your objective here on this one, is to predict the velocity of the green cart. So we're going to know the mass of the blue cart coming in and going out, but you won't know the mass of the green cart. So I've just pulled the window over so you can't see. Okay, 1, 2, 3. The blue cart coming in was coming in at 0.897 meters per second. It then bounced off of the green car and returned with a negative 0.158 meters per second. Your job is knowing the mass of the green car and the blue car. Your job is to solve for the velocity of the green car. So the velocity of the green is going to be your x when you set up the calculations. So that's what we're solving for. The fourth one is an inelastic collision. So it's very similar to the elastic collision in terms of the setup. But what I need to do is flip the car around, because there's Velcro right here at the end of the car. We want that Velcro to line up with the Velcro on the blue car. As they stick to each other, they're going to move off in that direction. And so that's what we want to find the speed of, is that final velocity. Okay, so to set that up, it's going to come in similar to the last one, but it's not going to bounce off. It's going to move forward with it. Mass of the blue car is the same. Mass of the green car is the same. All right, 1, 2. So the mass of the blue car coming in is 0.708 meters per second. Your job is to solve for the velocity of the blue and green. So the blue and the green speed is going to be your unknown. We're going to take the load here, which has a mass of 0.492 kilograms. And while the blue cart is rolling across like this is going to be dropped into it. Now it's probably not going to land as perfectly as that, but we'll give it a shot. I'm going to make an effort to just keep my hand here and have this roll towards me. So like that, and have it keep rolling. Okay. That doesn't look too bad. We've got a speed right here that we need of 0.533. So see if that works for you.